Okay, so I wanted to make a separate video for this one because I felt like the other one was already long enough. So I figured this one would be optional, okay? So this is the word problem for the second part. So it says a sailboat leaves a pier at and heads due west at 16 knots. After 30 minutes, the sailboat changes course to south 33 by southwest at 18 knots. Find the sailboat's bearing and distance from the pier after 45 minutes on the course. Okay, so that's the word problem. Now I'm going to go ahead and draw it for you. I figured the drawings are going to be one of the hardest things, so I figured I'd draw them with you. Okay, so this one's definitely a little bit different. So again, here's A, and then A is at the pier and it's traveling west. Okay, oops. I don't know why I can't draw straight lines. Okay, so and I'm going to call that B. Okay, so it said it traveled for 30 minutes, 16 knots. So I'm going to go ahead and find the distance. So 30 minutes would be 30 over 60, or 1/2 times 16. And that gives me 8 nautical miles per hour. Okay, 8 nautical miles per hour. Then it said that it traveled south by southwest 33 degrees. So basically, that ended up here. Okay, and it ended up going in this direction, 33 degrees. So I'm just going to go ahead and draw this now. Okay, so we want to find the distance from, let's call that C, from A to C. Okay, and I'm going to erase that. So this is the distance we want to find. Okay, so from A to C. Okay, and again, this was supposed to be a perfectly straight line, so I just want to remind you there's a 90-degree there. Okay, and then the distance traveled here, this was, they traveled for 45 minutes, 18 knots, so that's the same as saying, let's see, because I may not have enough room. 45, I'm going to write a ratio, 45 to 60, and that's the same as saying 3/4 times 18, which will give me approximately, well, not approximately, 13.5 nautical miles. Okay, so technically this is the drawing without anything else. Okay, we know this much. So remember, again, just like before, I'm going to kind of extend this and complete it to make it a right triangle. So let me see if I think I can use this one. So I'm going to draw, you have to imagine this line is perfectly straight and I'm drawing it just to complete this triangle. So I'm going to draw another right triangle there. Okay, and I will call this, let's see, A, B, C. I'll call this D. And then again, just like earlier, not to confuse you, then I'm just going to call this X and Y, and then we'll call this Z. Okay. So this is all the stuff we know so far. Okay. And truth be told, remember we were working with this triangle earlier. Like, if I had to reference it to the example before, if I had to choose between this angle or this angle, it's easier to find this angle. Okay. Now, if you're wondering why is it easier, because I know this angle is 90 and these two together have to add up to 90 because all three are supplementary. And over here, I know nothing. Okay. So it's easier to find this one. So to find this angle right here, I'm just going to subtract 90 and 38. No, I'm sorry. See, that looks like a 38. This is 33. Let me make it look like a 33. 90 and 33, which is basically 57. Okay. So this angle right here is 57. Okay. Oops. Sorry for the shaking. Okay. So just like before, you guys, again, I don't care to actually find an exact value for X or Y. I'm just going to set an algebraic expression to solve for it. Okay. So, okay, this time let's do it correctly. I'm going to solve for X. So X is adjacent and I know the hypotenuse. So that's cosine. So I'm going to do it here. So cosine of 57 equals X over hypotenuse, which is 13.5. Okay. So cosine of 57 equals x over 13.5. And again, if I cross multiply and solve for x is going to be cosine of 57 times 13.5. Okay. And this is what you have to remember. So now let's do the same thing, but let's do it for y. So I'm going to do opposite and hypotenuse. So now I'm going to work with sine. So sine of 57 equals opposite, which is y, over hypotenuse, which is 13.5. Okay, again, cross multiply, isolate y, you get y equals sine of 57 degrees times 13.5. Okay, and these are the two you have to remember. Okay, what x and sine is. Okay, so remember our goal is to solve for z. So what's going to help us is to find this angle. Again, don't solve for this one because it's too complicated. There's too many unknowns here. So it's easier to find this one. Okay, so ready? We're going to set this up. So now I'm going to use my second whiteboard. So I'm going to use tangent. So opposite is y and adjacent is x plus 8. So here we go. I'm going to move that one out of the way. So tangent of angle A equals opposite, which is y, over adjacent, which is x plus 8. Okay. But now we're going to substitute our values. So y is sine of 57 degrees times 13.5, and x is cosine of 57 times 13.5 plus 8. And boys and girls, you could save a little bit of work. Instead of plugging this in your calculator, go ahead and do one more step. Since we're going to be solving for a because we don't know what a is, and you could just now at this point say a equals tangent inverse, and then just plug this in your calculator. Sine of 57. Why not? Otherwise, you're going to be plugging in it twice. So just do it one time. Don't plug anything in your calculator. Just do the work here. Isolate a. So sine of 57 times 13.5 over cosine of 57 times 13.5 plus 8. Okay. All right, all that. Now calculator time here. Ready? Let me erase anything that I have there. Tangent inverse. Let me write it as a fraction. And then we want sine of 57 degrees. Okay, close it, times 13.5 over cosine of 57 degrees times 13.5, but plus 8. And remember, this is going to give us our angle right away. So our angle is approximately 36.4. Okay, I'm going to go ahead and keep it as a decimal. Oops. Sorry, I just noticed it's out of focus. Okay, so 36.4. I'm going to keep it. Okay, so A is approximately 36.4. Okay, now coming over here, how did that help us? That 36.4, 36.4, oops, I'm out of focus. Okay, 36.4 is this angle right here. So what we could do right now is go ahead and find the bearing, okay? Our navigational direction, okay? So remember, it started off here and then it basically traveled this way, okay? So we want to find out our navigational bearing. So all I'm going to do is draw my 90 degrees. And basically, I want to know my distance traveled. So this angle right here. Okay. And so let me use a different color. Let me use brown. So basically, take 90 minus 36.4. So 90 minus 36.4. And you get 53.6. So this angle right here is 53.6. So remember, it's southwest. So it traveled this way, okay? Southwest, because it went this way towards C. So this is our bearing, 53.6 degrees south by southwest. Okay. And so pretty much now we have everything that we need. Now we just have to find Z. Okay. So let's do that. Okay. So now I'm going to use, let's see, I'm going to use tangent. So tangent of angle A is opposite, which is y, over adjacent, which is x plus 8. Okay. But remember, I know a lot of this stuff now. Tangent of angle A, well, angle A we said was 36.4. Okay. Y we said was sine of 57 degrees times 13.5. Okay. And then X we said was, what did we say X was? Where's X? Okay. Cosine of 37 degrees times 13.5 plus 8. Okay. So I am going to put this in the calculator. All right, scratch that. Man, I was trying to go through an entire video without making an error. I apologize. We're solving for Z. I lost track there. So do not use tangent, because tangent was y and x. And then as soon as I was going to start to put in the calculator, I was like, wait a minute. I have everything that I need. So excuse me. So instead, how about we do sine? Opposite over hypotenuse. Okay, so let's work with sine. Don't use this one, or you can, but if you use this one, it would be these two. Okay, so this one or this one, not these two. I use tangent and I shouldn't have, because I have everything. So we're solving for C. So let's try that one more time. So I should have sine of angle A equals opposite, which is y, over hypotenuse, which is z. There we go. Now substitute your values. So sine of A is 36.4 degrees. Y was sine of 57 degrees times 13.5. And Z is our unknown. See, we needed to have an unknown, and that's when I realized, wait a minute, I knew everything. All right, so cross multiply, solve for Z, and you'll end up with Z equals sine of 57 degrees times 13.5 over sine of 36.4 degrees. Okay, so now we're going to put that in our calculator. So here we go. Again, I'm just going to use the fraction feature. Okay, and it's out of focus. Okay, so sine of 57 degrees times 13.5, and it's out of focus. Okay, over sine of 36.4. And I get approximately 19.08, I'm going to go with. Okay. So Z equals 19.08, and it's an approximation. Okay. And so this is our distance. So this would be nautical miles. Okay. So now if you're wondering, okay, what is our final answer? What is our final answer looking like? Okay. So 2 answers. Okay. Ready? I'm going to erase this. So pause the video so you can copy that down if you need to. But let me erase this. Our 2 solutions should be our bearings. And remember, bearings is written as our angle. So we had gotten, what was our answer? 53.6. So it was south by 53.6 degrees by southwest, and then our distance was 19.08. Again, I rounded it to 2 decimals. You can round it to 1 nautical miles. So this is our final solution. Okay. All right, I gave you 2 and they were pretty long and extensive, so I think you should have more than enough to try today's examples. No more videos. You're pretty much just going to wrap this up, and then we're going to do some review. Okay? All right, boys and girls, good luck.